In American school books, the story of electricity feels settled. Edison perfects the light bulb, Tesla tames alternating current, and from the Gilded Age onward, the United States lights up in a blaze of human genius and industrial progress. You can almost picture the timeline as a clean line moving upward. Candles, gas lamps, dynamos, power plants, smartphones. Neat, satisfying, closed. But what if that line is not a beginning, only a splice? What if Edison and Tesla did not invent the electrical age so much as reconnect a system whose remnants were already all around them, built into the very brick, stone, and metal of American cities? Walk through almost any historic American downtown and look up. You will see them once you know what you are looking for: needle-like spires on civic buildings, bulbous domes on courthouses and capitals, forests of ornate finials, urns, and seemingly purposeless metal rods puncturing the skyline. They are described in guidebooks as decorative, as stylistic quirks of Beaux-Arts or Second Empire architecture. They are aesthetic. They are symbolic. They are just how they built back then. And yet these same elements, spires, domes, metal crowns, appear with eerie uniformity on structures erected within a narrow window of time, roughly the mid-19th to early 20th century, across the entire industrialized world. Town halls, post offices, courthouses, train stations, exposition halls, all bristling with metal, all crowned with forms that just happen, coincidentally, to resemble high-voltage hardware, resonant cavities, and capacitive collectors. The official story is that these buildings were monuments to civic pride. The unofficial story, the one whispered in archival footnotes and buried photographs, is stranger, that they may have been the visible terminals of a forgotten atmospheric energy system, a network that harnessed the sky long before Edison filed his patents and Tesla set foot in America. So the question is not simply who discovered electricity. Americans already knew lightning, static shocks, and mysterious forces for centuries. The question is far more unsettling. Who owned the grid before there was a grid, and did Edison and Tesla merely switch part of it back on? Part 2. Spires, domes, and the architecture that behaves like hardware. If you start from the assumption that all those spires and domes are just pretty decorations, the built environment of 19th century America is eccentric but harmless. Yet when you strip away the story and look at the engineering patterns, something else begins to emerge. Across the United States, from Boston to San Francisco, older civic buildings from the 1800s share three recurring features: tall, slender spires terminating in metal tips or clusters of rods, large domes constructed with precision curvature and metallic crowns, dense constellations of small metal elements along ridgelines, parapets, and cornices, finials, orbs, speaked urns, and grotesquely overbuilt lightning rods. The explanation offered today is simple: lightning protection, symbolism, and Victorian excess. But that explanation starts to fall apart under close scrutiny. If these are merely lightning rods, why are so many of them isolated from direct grounding paths, perched on insulating bases of stone or terracotta, or connected to strange internal cavities rather than simple down conductors? Why do some towers hide complex metal frameworks inside, instead of a single rod and cable? Researchers poring over old construction photos and plans have noticed patterns that align less with religious or civic symbolism and more with system design. Domes are not just domes, they are tuned cavities, constructed to exact ratios that favor acoustic and electromagnetic resonance. Spires are not random points. They follow standardized heights and proportions across different cities and continents, as if obeying a set of design tables that no school now teaches. Inside these buildings, the anomalies multiply. Many contain basement tanks or sealed vessels with no clear plumbing function, chambers that respond to changes in air pressure, and voids that appear engineered rather than incidental. Their acoustics are extraordinary. Certain frequencies are amplified, others canceled, and sound can linger far beyond what typical masonry should allow. If you were designing an atmospheric power system that drew charge from the air, stored it in the mass of the building, and redistributed it through a network of conductive elements, you would build precisely this kind of architecture: a dome acting as a resonant collector, spires and finials serving as antennas tuned to local conditions, subterranean vaults and vessels functioning as capacitors or pressure-linked converters. What we call style begins to look suspiciously like infrastructure, and the uniformity is the giveaway. Cities thousands of miles apart, Philadelphia, Buenos Aires, St. Petersburg, San Francisco, erected buildings with nearly identical energetic features within the same narrow span of decades. They did so, according to mainstream history, with minimal international coordination, primitive communication, and no shared electrical standard. Yet the towers, domes, and metalwork obey the same invisible rules, as if the architects were following a system diagram they themselves did not fully understand. Part 3. Airships over America's Stone Machines. If these buildings were components of an earlier energy network, someone had to install them with precision. And here, the record takes a turn from strange to outright impossible. A trove of 19th-century photographs from archives around the world shows massive, lighter-than-air craft hovering directly above large public buildings during critical stages of construction, domes being lowered, towers assembled, giant prefabricated blocks suspended in mid-air. These are not advertising balloons or circus stunts. The images are matter-of-fact: an airship holding a dome segment steady while workers secure it, cables descending from gondolas to rooftop rigging, entire clock towers lowered into place as single units. Captions in municipal archives read like routine work logs. Installation of dome structure, June 1893. Positioning of bell tower elements, October 1887. No fanfare, no wonder, no suggestion that anything unusual is happening. Yet modern aerospace engineers insist that airships are too unstable for this kind of surgical lifting work. Wind, thermal shifts, and pressure changes make such maneuvers wildly impractical, if not impossible. And still, photograph after photograph documents exactly that happening. Not in one city, not as a one-off experiment, but across continents, for decades. Then, as abruptly as they appear, the construction airships vanish from the visual record. Around 1910 to 1912, they are simply gone. There is no gradual transition, no heightenedly publicized debate about abandoning a key technology, no clear replacement other than cranes and scaffolding that had supposedly existed all along. If the buildings themselves are machines, these airships look suspiciously like installation tools belonging to the same older system, last surviving service vehicles used to repair or retrofit an infrastructure no one wanted to admit was inherited. The logistical patterns support this: prefabricated architectural elements arriving at ports with no clear manufacturing origin listed. Shipping manifests that describe structural units without naming makers or factories. Municipal records that document use of aerial lifting systems in bland terms but omit technical detail entirely. Crucially, archives show a second pattern: systematic erasure. Photographs are scratched specifically where cables attach to buildings, captions are truncated, and patents related to aerial construction filed between 1880 and 1910 are destroyed in fires or placed under national security seals that, in some cases, remain active. So whatever those airships were installing, domes, spires, mysterious conductive elements, it was important enough to use advanced airborne machinery, and controversial enough that the how had to be buried. Which brings us back to the skyline. If the network those craft serviced was an atmospheric power system, then those spires and domes still sitting silently atop American buildings are not relics of style. They are dead terminals of a shut-down grid. Part 4. Railroads as a hidden electrical grid. Whenever Americans talk about the 19th century, the railroad looms as the symbol of progress. Steel rails, steam locomotives, and grand stations heralding a new age of movement and industry. The story feels complete. You do not ask what a train station was for beyond trains, but stand in Grand Central Terminal in New York, Union Station in Washington, D.C., or the older depots that survive in smaller cities, and a different truth presses in. These buildings are vastly overbuilt for the needs of ticketing and waiting rooms, cavernous halls with ceilings soaring over 100 feet, stone and marble everywhere, as if designed to endure enormous thermal and mechanical stress. Intricate ventilation shafts, vast basements, mysterious mechanical rooms whose original equipment is missing or mislabeled. The official explanation: civic pride, architectural rivalry, cathedrals to steam. But heating and lighting these spaces with coal and gas, as we're told was done, would have demanded boiler complexes and fuel deliveries on a scale that should dominate the historical record. Blackened interiors, soot-coated sculpture, massive smokestacks, armies of stokers, detailed engineering drawings. Instead, photographs from the era show pristine surfaces, clean ceilings, and curiously modest boiler rooms, if any are documented at all. Then there is the electricity problem. Many of these stations exhibit evidence of fully integrated electrical infrastructure years before the local grid, as described in textbooks, should have existed. Plans show conduit channels built into foundations and walls long before the supposed arrival of commercial power. Rooms that look precisely like substations are relabeled as storage. Consumption records hint at megawatt-scale loads with no corresponding nearby power plant. Step back and consider the rails themselves. Two parallel metal conductors separated by ties, stretching in geometric precision across a continent, connecting major nodes, stations, spaced at regular intervals. From an electrical standpoint, this is an almost ideal backbone for a large-scale distribution system. Now, picture the station buildings as receivers or converters, sitting at junctions where thousands of miles of metal converge. Copper roofs and metal crowns acting as atmospheric collectors. Massive stone foundations providing grounding and stability. Tower structures functioning as transformers or tuning elements. Suddenly, the layout of the American Railroad map starts to look less like a transportation plan and more like a repurposed power grid. Energy could be harvested from the atmosphere, captured by certain buildings, transformed, and routed along rails that just happen to be everywhere. Passenger service may have been a secondary or later function, adapted once the original system failed or was shut down. Time itself betrays the deeper purpose. In 1883, competing American railroad companies did something unprecedented. They abolished local solar time and imposed standardized time zones across the continent, on a single day, without government decree. For 35 years, the United States lived by railroad time before Congress made it official. We are told this was done purely for scheduling convenience. Yet any engineer working on synchronized energy systems will tell you that shared timing is not a luxury, it is a requirement. Large distributed networks, electrical, mechanical, or otherwise, must operate to a common clock. If the rails were once part of an energy system, not just a logistics network, the sudden imposition of uniform time begins to look less like scheduling and more like the last phase of commissioning a synchronized grid. Then, as with the airships, construction of the monumental cathedral stations stops. Post-1920 terminals trend utilitarian, scaled strictly to transportation needs, stripped of the ornate domes and elaborate towers that once defined the type. Older stations are demolished or gutted, their mysterious infrastructure removed and replaced with modern equipment. An era of forbidden energy ends without anyone officially admitting it ever began. Part 5. Niagara, Jacksonville, and the Buried Power Vaults. If American architecture and railroads hint at a lost electrical order above ground, places like Niagara Falls and Jacksonville, Florida, provide the evidence below. In 1896, as engineers excavated beneath Niagara Falls to build what would be hailed as the first great hydroelectric power station, they punched through bedrock and into a nightmare for neat historical timelines. Beneath the riverbed, deeper than expected geological layers, they found chambers lined with high-temperature ceramics designed to handle power densities far beyond anything planned for Tesla's generators. Perfectly symmetrical cylindrical housings, machined with tolerances more like modern turbine shells than 19th century mill equipment. Conduit networks integrated directly into the rock, laid out in an organized grid that extended far beyond the footprint of the new plant. Internal notes from that year repeat a quiet phrase: pre-existing infrastructure, unexpected depth, origin unknown. Public reports, however, wave the findings away as old mill tunnels or natural formations. Photographs tell a different story. Workers dwarfed by conduits large enough to stand inside, surfaces polished to a near frictionless finish, crystalline structures fused to metal in patterns that suggest engineered electrical properties rather than random mineral growth. And then, just as deeper sections are documented, the project changes character. Chambers are backfilled, entrances are sealed. The most advanced and inexplicable structures are buried first, while more mundane or geologically unstable areas are left accessible for turbine installation. The official explanation invokes safety and deadlines. The pattern looks more like suppression. Half a continent away, in 1901, Jacksonville burns. 146 blocks destroyed, over 2,000 buildings gone. As crews clear the wreckage, they dig below familiar basements and encounter something that should not be there. An extensive underground district laid out in a coherent grid, with streets, sidewalks, and building foundations. Monumental brick arches and support columns engineered to bear far greater loads than the wooden city above ever required. Ventilation shafts, carefully spaced and brick-lined, designed for air circulation rather than water drainage. Early reports mention more than 1,700 distinct subterranean structures, an entire buried city beneath the known city. Those numbers vanish from later documents. Maps that once mark lower development or basement district are quietly revised to show featureless ground. Property records remove references to underground access. Again, the most intact, precisely built sections are the first to be refilled and sealed. The rationale, once more, is safety. But like Niagara, the logic is inverted. What is strongest and most sophisticated is buried. What is fragile is left. Both sites, Niagara with its power-grade underground infrastructure, Jacksonville with its overbuilt, ventilated, and aligned subterranean city, fit into a larger pattern. America building its visible modern systems on top of something older, more advanced, and studiously denied. If these buried chambers and grids belong to a prior energy civilization, then the first American power stations and modern cities did not inaugurate the age of electricity. They cannibalized its remains. Part 6. Myths of Inventors, or Men Who Found the Switch. This brings us back to the men every American student can name: Edison and Tesla. In popular mythology, Edison embodies relentless iteration. Tesla, visionary genius. One gave us practical electric light, the other the AC system that powers the nation. But consider their work against the backdrop of the evidence. Atmospheric, collector-like domes and spires baked into pre-existing building stock. Rail corridors that function perfectly as long-distance conductors. Subterranean power-grade infrastructure predating the first grids. Systematic erasure of documentation, from aerial construction patents to underground maps. Tesla, famously, dreamt of wireless energy, atmospheric electricity, and global resonance. He built experimental towers and spoke in terms of the Earth as a conductor, the sky as a reservoir. Yet his most ambitious projects were mysteriously underfunded, sabotaged, or abandoned. Edison, for his part, fought to control not the phenomenon of electricity itself, but the distribution, the meters, the billing, the patents, the locks, on who got to sell power to whom. Now imagine a scenario in which both men were, knowingly or not, tapping into principles that an earlier civilization had already mastered at scale. In such a scenario, Edison's incandescent era is not the birth of artificial light, but the commodification of a narrowed, controllable subset of a much broader energy system. Tesla's atmospheric visions are not leaps into the future, but dim recollections, through intuition, through fragmentary evidence of what the domes, spires, and buried chambers around him were already designed to do. The myth of the lone inventor is convenient in a world that needs clear ownership, patents, and corporate hierarchies. It is far less convenient if the real story is that America, and the modern West at large, inherited a landscape studded with the hardware of a prior grid, an atmospheric, architectural, and subterranean system whose operators, designs, and manuals were wiped away. You can see the traces almost anywhere in the United States if you know where to look. A courthouse dome humming with uncanny acoustics, crowned by a metal lantern that no longer connects to anything. A former train station, now a food hall or museum. Its colossal hall, overbuilt for commuters, but suspiciously well-suited to house equipment. A city that modernized its streets by raising ground level, leaving arched windows and doors half buried, their original purpose a mystery. The official story insists these are coincidences, that the spires are symbolic, the domes aesthetic, the vaults over-engineering, the airships promotional stunts or photographic illusions, that Edison and Tesla represent a clean beginning. But once you place their lives on the timeline that also contains Niagara's buried conduits, Jacksonville's underground grid, the vanished construction airships, and the meticulously erased blueprints of grand stations, another possibility refuses to go away, that the true inventors of the electrical age are nameless, their works misattributed, their network dismantled or shut down in the late 19th and early 20th centuries, and that Edison and Tesla, brilliant as they were not so much creators of a new energy world as men who groped along the darkened walls of an old one, found a few surviving switches, and turned them back on in ways that could be metered, billed, and controlled. If that is even partially true, then the strange crowns and needles on America's oldest buildings are not architectural flourishes from a naive past, but the fossils of a lost electrical sky, one that once hummed above the United States, sending invisible currents down into stone and steel, long before we were told the lights came on.